In this video, we're going to be finding from our three forms of linear equation, slope, intercept, point slope, and standard form, points of interest. That is, we are going to be finding points that are on these lines, that are solutions to these equations. Recall that an equation is linear if it represents a linear function. That is, when you graph it, it's a straight line. And in order to describe a linear equation, and this is key to what's going on here, we need either 2 points or a point and a slope. You already know how to find the slope from all three forms of these equations. So now we're going to find that other piece, that point, or in the case of standard form, 2 points that we need to describe this linear equation. So recall our three forms: slope-intercept form, y equals mx plus b; point-slope form, y minus y sub 1 equals m times quantity x minus x sub 1; and standard form, ax plus by equals c. Now you'll notice in slope-intercept form, we've talked about slope. The part we haven't discussed is what an intercept is. An intercept of a function is the value of either the domain or range, so that's either the x value or the y value, when the other one is 0. So we can talk about the x value when the y value is 0, or the y value when the x value is 0. But the key is that one of them will be 0 at these intercepts. If we're looking at a graph, the intercept is where the line touches one of the axes. So if we're looking at an actual line, we have 2 intercepts that we can look at here. We have our x-intercept, which is where the line crosses the x-axis, which is the horizontal one. So here you can see it crosses at -2, 0. And so notice the x-intercept is an x value when y is equal to 0. The y-intercept is where the line crosses the y-axis, 0, 6 in this case. And notice again that it is the y-intercept, 6, is the y value when x is equal to 0. Now we can discuss how to find these points from the equations themselves. Slope-intercept form, which you have now known about for literally years, tells us that we have the form y equals mx plus b. We've already established that m is the slope, and it turns out that b is the y-intercept, and thus a point on the line. So our y-intercept will be at 0, b, and that is just the point on the graph where this will cross the y-axis. Another way of looking at this is you can just go to your y-axis and put a dot on whatever number b is, 2 in this case, and that gives you a point on the line. Point-slope form is a little trickier. Our point from the line is just going to be x sub 1, y sub 1, which doesn't seem too tricky. Most people would look at that and say, oh, well, the point on the line would be -1, -6, except that that is not correct. Notice that in the equation, it's minus y sub 1 and minus x sub 1. So the moral of the story is that when you are finding the point from this, you have to find x sub 1 and y sub 1 in the equation, and the point will actually be the opposite of whatever you have in the equation. So here we have -1 in the general location of x sub 1. So our point would actually be +1. We have -6 over here, so our point would be +6. So you're almost just directly reading this point out of the equation. We just have to know to flip the signs of those two. Now in standard form, we can have now 2 points. It gives us the x-intercept and the y-intercept. So standard form is giving us all the goodies, but it's making us work for them just a little bit. To find the x-intercept, we have to find c divided by a, and for the y-intercept, we have to have c divided by b. So let's look now at some examples of finding a point from a line. If we look at these two, I have a y by itself on the left-hand side of the equation, tipping me off that both of these are in slope-intercept form. So knowing that they're in slope-intercept form, I need to focus on b, the number that is out here by itself. And that number is going to tell me about the y-intercept. So I can very quickly and easily say that if I need a point on this line, a quick, cheap, and easy one is to say, well, the y-intercept, that's where x is equal to 0, so the point 0, -9, is a point on this line. So if I needed to, say, graph this line, here would be the first point that I could draw on that graph. Likewise, over here, we know that 2 is the y-intercept, and at the y-intercept, x is 0, and then the y value is just 2, read directly out of the equation. So if we have slope-intercept form, very, very straightforward to find that point. Now we're going to move on and we're going to look at two examples that are point-slope form. In example 3, I see the parentheses, which tip me off. In example 4, I don't have the parentheses, but I do have a number added or subtracted to y on one side of the equation, and y and x are on different sides of the equation. So both of these are in point-slope form. Remember that example 4 is the one we looked at where the slope is 1, and thus the parentheses go away. So looking at this, I need to identify x sub 1 and y sub 1 because that's where my point's going to come from. And in doing so, I want to look at the number paired with x and the number paired with y. However, remembering that in my exemplar equation, I'm subtracting these, that means to find x1 and y1, I have to take the opposite of those. So x1 would be the opposite of positive 4, which is negative 4, and y sub 1 would be the opposite of negative 1, which is positive 1. So now, by taking those and reversing the sign, I found a point on my line. Same thing over here. I need to find x sub 1 and y sub 1. X sub 1 will be paired with the x, what's added or subtracted. Y sub 1 is paired with the y, but when I write them as a point, I have to reverse their signs. So the opposite of negative 4 is positive 4. The opposite of positive 3 is negative 3. Finally, a clever student might note that since we've looked at slope-intercept and point-slope form, this is most likely going to be standard form, and indeed, clever student, you are correct. Our x's and y's are on the same side of the equation, which is our tip-off that this is standard form. And in standard form, I can actually find the x-intercept and the y-intercept. So I'm going to find not one, but count them 2 points on this. The x-intercept is going to be c over a, and the y-intercept is going to be c over b. So notice that I really have to know what all 3 of a, b, and c are. So a, looking at our equation, is the coefficient of x, which is 10. B is the coefficient of y, which is positive 5. And c is the constant term by itself on one side of the equation, so in this case, 30. So my x-intercept is going to be equal to 30 over 10, which is 3. And my y-intercept is going to be 30 over 5, which is 6. Now I really want to turn those into points. So I have to remember that at my x-intercept, y is going to be 0, and so my x-intercept is the point 3, 0. And for my y-intercept, well, at the y-intercept, x is 0, and my y-intercept value is 6, so this is going to be my y-intercept. And now I have not 1, but 2 points from that line. And I can do the same thing over here for example 6. I need to identify a, b, and c. A is negative 4, B is -1, and C is 8. For my x-intercept, I know that that's going to be C over A. So in this case, 8 over -4, which is -2. My y-intercept will be C over B. C is, of course, 8. B is -1. 8 divided by -1 is -8. So now putting them together as points, for my x-intercept, the y value will be 0, and the x value will be what I calculated, -2. And for my y-intercept, x will be 0, and y will be -8. So now I've found not 1, but 2 points from that line.